All right, everyone, good morning. Welcome to a nice Tuesday morning here in beautiful New Orleans. My name is Kenan Owens. I'm a technical product manager on the Windows Server System Center team, focusing mainly on virtualization. And so main focus is going to be Virtual Machine Manager. To my right here is Michael Leeworthy. He's also on my team. He focuses on Operations Manager, Application Performance Management, that type of thing, as well as the new, Catal, Windows Azure Pack, that kind of stuff that we talked about yesterday. And to his right is Juan Hu. He is also on my team, and he focuses on Operations Manager and our cross-compatibility with Linux and other operating systems. This session today, we're focusing on what's new in System Center 2012 SP1. So we came out last March, April with System Center 2012. Then Windows Server came out in October. And we came out with Windows Server 2012 SP1 at the beginning of the year, this year, to focus on support for Windows Server 2012, as well as to move us closer to that CloudOS vision that Brad was talking about in his keynote yesterday, which also leads us to the 2012 R2 stuff that there are other sessions on. They're going to talk about that during TechEd here today. We're going to focus on the data center. So what's new with System Center 2012 SP1, focusing on data center topics. Mainly all the other System Center products besides Configuration Manager. So like I said earlier, if you're looking for Configuration Manager information, there's a SP1 session right down the hall. I think it was room 278 or something. It's in the Windows Client section, the WDC or whatever those, the WAC, no, WCA session codes. So we're going to focus on the other ones. And the order is going to be, we're going to talk about Application Performance Management first. Then we're going to talk about Chargeback and Automation. We'll talk about Operations Manager and Monitoring, Data Protection Manager, and then Virtual Machine Manager. So with that, what I'm going to do is I'm going to pass it over to Michael so he can start talking about Application Performance Management.
Great, thanks very much. Okay, let's have a look here. Well, I'm going to jump straight into the new capabilities for SP1. So APM is one of these really interesting ones to talk about because from a technology point of view, it's a super simple technology to deploy in most of your organizations, but it's not really highly utilized. And what we're trying to do is just show you generally how easy it is to deploy some of the new advantages you can get to it, especially in supporting custom applications. If you've got developers that are building traditional modern apps, there's definitely a bunch of things that are available in the SP1 timeframe that can help with that we actually then push the boundaries on with System Center R2 as well. So I'm going to talk a little bit about the SP1 stuff. I'll show you some hints of what we're going to do in R2, just to give you an understanding of where we're taking a lot of this type of stuff. But as Kenan said, we have 20 other R2 sessions that got released yesterday, so make sure you check your online guides for that. But around SP1, we really try to just extend the footprint of our application performance monitoring. For those of you who might be new to what APM actually is we focus on in two main areas, server-side monitoring and client-side monitoring. So the ability to look at the performance and reliability of an application, either a .NET application or some sort of custom application utilizing the .NET framework, or alternatives like that, WCF applications, SharePoint applications. And what we try to do is look at two main things. We want to look at the performance from a client point of view. What are the times it takes for certain aspects, components, objects, or models to be launched in that time frame? So we do this by injecting code into the actual application, which runs in the browser. So effectively, every time one of your customers or one of your employees opens that application, you can actually then capture information, send that back to Ops Manager, and then sample that to understand the performance of that application over time, and they get viewing, and then make determinations whether that application is either failing or it's not meeting its SLA environments. On the other side, we have the server-side monitoring, which is where we can do code analysis. So basically, as the application runs, we're monitoring certain performance, certain reliability, certain availability aspects of that application, and then we can make determination on, if we're getting failings, exactly what type of code is failing, what are the parameters, what is the stack that's causing that issue, and we can also get down to a line of code, which is really quite interesting. In SP1, we really tried to push our boundaries in supporting a lot more than just the .NET framework applications that we had in the 2012 timeframe. So now we can use, Monitor MVC and WCF applications, and also .NET applications hosted in Windows services. Again, just really trying to just round out our services here. One of the new things is we now have IntelliTrace and TFS integration. So understanding there's a problem is just half the issue. Right, and definitely as an ops manager person, we're not developers. So when we look at an application that's failing, you have to make a determination exactly why that's failing. Is it network? Is it server related? Or is it application related? Because it's hard for me to go over to my developer organization or my application organization and say, it's your fault why this application is failing. Because they'll go, no, it's not. It's your fault. Your network's slow, or your server's not working, or you deployed it wrong. So what we want to do, and you've got that, and you're going to have that Chinese wall between each other. You're going to have that communication wall between each other. So the concept is you want to gather as much information as you possibly can and provide them everything that they need to trace and track the performance issues of that application, and let you really make an educated decision exactly what's going wrong. Now, with the great things that these guys are going to show you around Ops Manager, you can discount all the networking, all the server, all the typical IT infrastructure faults that may cause that application performance issues. You can discount them, make a determination that that's an application error, and then capture all the information associated with that through IntelliTrace. And IntelliTrace is exactly what's going to capture is all the stack information and dump information and debug information that when you throw it to the developer, when they open it up into their Visual Studio tools, it will then zone down to the single line of code that's causing the issue, and probably pretty much most cases tell them what the issue is. So it's, the whole idea of, lowering the mean time to resolution is the whole focus of our APM. And part of this, we want now to do TFS integration. Team Foundation Server is the debug, is the source control engine and bug tracking engine that developers use in the Visual Studio world. And we can actually integrate now our items engine in SCOM with TFS. So when I assign a bug to engineering, we actually have a link between these two as engineering or my developers are actually updating that bug. It gets updated in my database. They have access to the same tools that we do as well, so they can use the same debug tools that I can use in my APM world. So it's quite an exciting sort of way to break down the communication barriers between the operations world and the developer world. We've introduced a new dashboard in SP1 called the 360.NET Application Monitoring Dashboard. I'll show you an idea of this. What we've got so many monitors now around APM, we wanted to create a just out-of-the-box dashboard to make it a lot more easier. And of course, as Kenan said, one of the big advantages of SP1 is now we can monitor Windows Server 2012 and of course iOS 8. So that was one of the big improvements that we saw with the SP1 APM. We introduced some great new technology called global service monitoring, and I'm going to go quite deep into this because I think it's an easy thing to deploy in an organization. It's part of your software assurance benefit, and it's actually integrated into things like Azure now as well. So it's a great technology for you to utilize. There's a bunch of other things as well that we'll sort of go through. Now, when I talked about before, that we're starting to nearly extend the number of tests that we have in our organization around APM. So if you have a look at the APM sort of application health view, you sort of focus on three things: performance of the application, availability of the application, and reliability of that application. And we have about 3 or 4 core tests that we run. Performance monitoring, client-side monitoring I talked about before. So .NET application performance monitoring is our server-side monitoring, client-side monitoring, and this new technology we call global service. We also have things like internal synthetic transaction monitoring, which is sort of the ability to poll a website from an internal server and ensure the performance of that website, and a bunch of other things as well. And then if you look at our resolution and diagnostics, this is where I talked about that we have our resolution, we have our Team Foundation service, synchronization or IntelliTrace integration. And then from diagnostics, we have the IntelliTrace tracing tools and also the SCOM infrastructure monitoring management packs. So we have all these tests, and it looks like we have, looks like they're they're complex to deploy, but effectively they're all management packs. The way you deploy a management pack in your organization to manage a workload or infrastructure is exactly the way you deploy an APM management pack. And then we have a number of dashboards and tools associated with that. As I said before, we've introduced this new thing called the 360.NET Application Monitoring Dashboard, which is really just a dashboard template that brings all the views of these tools into one environment and then hooks it into your SLA engine. APM is all about SLA. Yeah, APM is great in understanding the fault of code, but most APM is associated with SLAs. And what you want to do in your organizations is you're going to sit down with your app owners or your dev owners and define what those SLAs are. I need my website to launch in under 3 seconds. I need this object model to do this in 5 milliseconds. And this is what the devs are going to do in their load testing. You can take all that SLA load testing and load that into Operations Manager and then hold Operations Manager accountable for tracking those SLAs and reporting on those SLAs. Because that's effectively what's going to drive your results on whether there's a failure in your APM engines. So one of the big things that we wanted to introduce in SP1 was the ability to do things called outside-in monitoring. Now, traditionally, APM has all been around inside-out monitoring, where I'm using my Operations Manager capacity to monitor the application itself. So, from a server-side monitoring, when the application is running an IIS, the Operations Manager is talking to IIS and understanding how that application is running and taking analysis of it. Client-side monitoring, when the client-side monitoring, the client loads the application, Operations Manager is receiving that information and analyzing that information. But I'm reliant on the customer opening that application at the time. What we wanted to think about is, one of the challenges when we talk to our customers is that, hey, I'm launching a new website in the northern, outside, I've got a hoster that's sitting in Chicago, and I'm launching a new website to that hoster, and it's going to live in that hosted infrastructure, or it's going to live on my infrastructure, or some sort of infrastructure in North America. But I want to know what the customer experience for that application is in Sweden, or Singapore, or Sydney, or Sao Paulo, or anywhere in the world. It's hard to test that. I could fly there and open my laptop and test that up. It's quite expensive to do that. I can build infrastructure there, or hire infrastructure, or lease infrastructure, which is generally what they do. Or there's some third-party, quite expensive tools that do this as well. But it's very hard to understand what the experience of your application is going to be like from somewhere around the world where you don't have an office, you don't have infrastructure. And we wanted to think about how we could do that with Operations Manager to provide this, and also take the burden of this sort of performance monitoring, this web transaction monitoring where the Ops Manager is always doing it. Take that out and just use Ops Manager as a collator tool. So we looked at how we could do this, and we came up with a great new technology called Global Service Monitor. And this is using Azure as effectively the monitoring agent, because we have a number of Azure points of presence around the world. So we rely on Azure as our monitoring agent and Ops Manager as the collector. So our concept is this. Like Visual Studio, your developers working in Visual Studio are going to create load tests. They're going to create unit tests and web tests to test their application. I don't want to have to recreate those. I shouldn't have to recreate those. They've spent a lot of time and effort in making great tests to test the boundaries of their application, and they've got all their SLAs in that test. So I'm going to take that test now in SP1, and I'm going to bring their entire web test into my infrastructure. So I don't have to rewrite any tests. I can take their Visual Studio test that they're using day in, day out, load that into my Operations Manager, and use that as the basis of my web test or my application test that I'm going to use. And then what I'm going to do is I'm going to take that web test, and I'm going to take a schedule every 10 minutes, every 15 minutes, every 20 minutes, every hour, every day, whatever my schedule requires. I'm going to load that up into the cloud, into this tool that we call Global Services Monitor. And now we have 16 points of presence around the world. So you can determine whether you want it to run in one point of presence or all 16. There's no charge to this. It's part of your software assurance benefit, so it's costing you bandwidth at this stage. And basically, Global Services Monitor is going to run that test for you per your schedule. So it's going to run that test every 10 minutes from where it is. So if you've got we've got one in Sydney, it's going to run that web test based on where my application is hosted, maybe in Chicago, and it's going to then record performance and analytics based on that, and then return that back to me in Ops Manager. So if there's an issue that it finds, GSM is going to push that into Ops Manager, and then I can use my normal APM understanding and techniques to understand if this is a bug, push it to the developer guys, and get that out. So it's a very exciting technology. So let me show you some examples of it. Okay, so Ops Manager is actually deployed as a management pack itself, so you'll find it in your administration, not Ops Manager, Global Service Monitor, you'll find it in your administration tools, and all you really need is an Azure subscription to get to it. As I said, it's part of your software assurance benefit. So once you've signed up for that, you have your, in your Azure, you've got your Azure subscription, you align it to our new GSM portal, you download the management pack, you deploy the management pack, and effectively at that stage, you're up and running. And then you've got a choice of 2 different tests you can run. You can configure a web application availability test. So this is when the onus is on sort of you to determine what that test is. The big thing about Ops Manager is it's not just testing your application. You can really test any web application associated with it. So let me show you what that is. So if I'm sure you've all done sort of this before. So basically, what you're going to do is it's just going to want a URL to monitor. And this could be anything. So we could actually, if we wanted to, monitor the health of Microsoft. Because I try to do that on a daily basis. Right? But basically, you would put your web in there. We could put forthcoffee.com or Contoso, which are our beloved companies that we tend to use all the time. But effectively, this is going to be the web address of your application. Now, the great thing here is you can put multiple addresses. So if you've got hosting in different areas, you can actually use the same tool to do that test that hosting in different areas. If you want to test different parts of your application or deeper subsets or trees of your application, you could do that all here and get the specific analysis of each of those application pages. So once you've got that, let me once we've got that, effectively this is when you're going to add your global points of presence. You can see here are my Azure global points of presence that are running our Global Services Monitor. And as I said, there's 16 at the moment. They're growing as we build Azure centers around the world. They're growing. We know that we announced China, so we'll be looking at Azure points of presence around that side as well. And this gives you the ability to really hone in from your application. You can also use internal options as well. If you've used web application transaction monitoring before in Operations Manager, this is really similar, except with web application transaction monitoring, your Ops Manager is doing the monitoring. In this case, GSM's doing the monitoring. If you add an internal location here, your Ops Manager will be doing that monitoring, but it'll be using the same tools, techniques, and reports of GSM, so it will just merge its reports and the GSM reports into one. So once you've got that, basically, from an app availability test, you have a bunch of configuration that you can do. When you want to run it, what the performance collection is like, what you're monitoring. In this case, it's monitoring for a 400 error, website down. I can say, if my transaction time is greater than 5 seconds, I want to know. That give me a red flag. You can see here I can do warnings, I can do request pages, I can capture huge amounts of information as I do through here. I can look for body text, I can do bunches of stuff like that. So I've got sort of that core ability to sort of monitor that performance and reliability of that application. And once that's done, effectively I deploy it out, it gets loaded up into GSM and I go. The other test I talked about before is I can configure a Visual Studio web test, and in this test all I'm really doing is loading the Visual Studio file, their web test file that they've created utilizing their web analyzer into GSM. So I won't walk you through that, it's exactly the same wizard. Now once you've got that, effectively you've got a number of new reports within Ops Manager to show. So we'll go and have a look at some of those reports. First one is the test state view. This just gives you a really quick glance view of the health of your applications, whether they're healthy or not. But you can see here we've got a couple of new views here that GSM provide. One of them is the detailed dashboard list, which allows me to go and look at all the information that's being captured from an application itself. So if I've got an application that's running a little bit sick, I can view that information in, and that takes about a minute or so to collate that information and pull that information, especially at the moment with our system sitting in Redmond. But one of the great things is the summary dashboard map. What this allows me to do is get that sort of view of the health of my application in those 16 Azure points of presence around the world. So the great thing here is that I have this sort of one quick view of this, whether the health of my application, whether it's running, whether it's not, and this takes sometimes 20 seconds, sometimes 30 or 40 seconds to pop up. But once I've got this type of information at my fingertips, it's easy for me to use my normal APM analysis view associated with that. So you can see here all that information's popped up. I know that most of the world I'm actually quite good, but I'm getting a little bit of issues down here in Singapore. I can view that information. And then I've got all the Ops Manager integration, so I can actually start looking at the Ops Infrastructure view and the Application Management view. Before I shoot out of that, one thing I do just want to show you, excuse me, is once you've got that information, what we'll do, if you've never seen it before, is I just want to show you a really quick analysis of our APM environment. Now, once you've started collating APM information, both your server and client APM information, you're really going to start to collate. You're going to start to collate a lot of different web test information. So you can see here, once I've implemented .NET monitoring in my organization, whether a client monitoring or server monitoring, and you do it pretty much exactly the same way. Deploy a management pack, reboot, restart an IIS server, and effectively you're up and running. And then you can go and determine your SLAs. So you can see here that you can get detailed information back. I just want to quickly show you some of the experience of here. So you can see here I'm getting server performance information back and client performance information back. So if we go and click on a server performance view, it has the normal Ops Manager stuff that you understand, that you've seen in an infrastructure environment. I can get product knowledge, I can put my company knowledge in, I can get my normal history associated with that. One of the new things, though, is the App Diagnostics. Now, the App Diagnostics tool is a web tool, and the reason it's a web tool is that this is the same tool that our developers can use. I can't type this morning, here we go. It's the same tools our developers can use to do analysis of their environments as well. And we didn't want to have that with an Ops Manager because I think developers would be scared a little to jump into Ops Manager world. So basically we have this web environment that developers can use. They have the access to the same App Diagnostics links, so they have all the information such as similar events, distribution chains, to understand if you've got an APM error that's going down a chain. They have access to performance counters, so they can pull in all the performance counters that you can pull in from Ops Manager. They can do that from a web view. So again, they don't have to go in the Ops Manager environment. Like IT guys, we don't want to go into their TFS environment, their Visual Studio environment. These guys don't want to come into the Ops Manager environment. This is a tool that we can share that's sort of been tailored for both environments. One of the big things nice things it does, though, it also provides a great visual representation of things going wrong. So I can quickly look at this and understand exactly the components going wrong. So when I have that discussion with the developer, I can say, what, our threshold's set at half a second. That threshold's coming in at about 1.1 seconds now. So we're getting a server-side module load time that's, I can start talking a bit dev. And they go, all right, we'll have a bit of a look at that. In that case, they're going to come in and look at sort of the stack trace information. And there's some amazing information you can get from here. To give you an example of some of the stuff that this provides, we can have a look at some of the blocking errors. And you can see here, this is when we actually get a lot of code information associated. So here are all the .NET parameter calls that have been captured. And I don't have the debug information associated, but if I had debug information, this would actually show me the exact code that's causing that issue. But this is when I actually can export all the IntelliTrace log associated with this, put it over to our developers, and then they have their debug systems. It hooks and links into the debug systems. When they open that IntelliTrace up in Visual Studio, it'll actually pull out the offending line of code, tell them the problem is, and then actually launch in the report. So it's a great way, again, to really bridge the boundaries between DevOps. A couple of things what we're trying to do in R2 is we now attach the IntelliTrace log into the bug. Before it was a manual download, which is quite good. The other thing we're extending is we're not only supporting just not .NET performance or .NET applications, but now supporting Java applications as well from an APM perspective. When we only supported the Java Enterprise Server infrastructure sort of monitoring, we're now extending both from .NET and Java apps. So with that, I'll hand over to Kenan. Say thanks very much for listening to me.
All right, Michael, thanks. So another thing I wanted to point out, in the expo hall in the TLC area, we have a group of people called our TED team, or now I think they've been renamed the CAT team, but they're this technical enablement team where they go into customer sites and they look at very difficult situations and they find solutions and they build custom solutions to enhance the things that happen with System Center and Windows Server. And they have a bunch of different sessions that they're going to be doing at the site. So if you want, here's a schedule. They're up front here and over here that you can pick up and look at them. These guys that go in and look at some of the really tough scenarios and find some interesting solutions. This next section, we're going to talk about service delivery and automation. Like we've said before, the biggest thing that we've done with System Center 2012 SP1 is support for Windows Server 2012 and the new release there. But the other thing we've done is we wanted to add some capabilities for our customers to be able to do more with the information that they're collecting via Ops Manager and VMM and tie them together better. So with System Center 2012, we introduced the Cloud Services Process Pack, and that was the ability for you to create a custom way of gathering information and deploying cloud services, creating more of a self-service portal with our service catalog, those types of things. With 2012 SP1, one of the things we wanted to add was the ability for that Cloud Service Process Pack to be able to pull out chargeback information. So we wanted to be able to allow you as an organization to create charge and show back information that you could pass back to your customers to understand how much they've reserved of your environment, how much they've deployed within your environment, so that you as an organization can gather more for cost analysis and justify, maybe that next purchase of servers and those types of things. So some of the biggest things that we've done is updated the Cloud Services Process Pack, integrate chargeback into there, build in connectors to Windows Azure. So within Service Manager, you can kick off things like an Orchestrator runbook. Within Orchestrator now, we've added a Windows Azure Management Pack, so you can connect into there. Support more and better support of the Windows Server 2012 capabilities inside of there, and extend out to some of the partners for integration packs. So we'll talk a little bit about both of those things. So first of all, chargeback. As an IT organization, you want to understand how your resources are being utilized. You want to understand when you may start running out of resources, and you want to, if you're moving more towards a service provider type view internally, you want to be able to charge back or at least show the organizations that are utilizing your resources how much they're using, both how much they've reserved to use and how much they're actually physically using, they've deployed and configured, so that you can justify the cost of IT. So what we want to do is we want to more drive behavior so that people aren't just deploying a bunch of virtual machines, having them sit there, and you're still having to charge or cover the cost of these resources. A lot of organizations within virtualization or even before virtualization, they had server sprawl where they just had all these servers that were out there that could have been sitting there for years and not doing anything, right? Well, when virtualization came out, it was so much easier to create these virtual machines. So now you had this virtual machine sprawl where you had all these virtual machines out there that are sitting there. They have to be deployed. They have to be patched. They have to be monitored. They have to fit into my organization as an IT, but they may not be utilized at all. People may have just deployed them out there, and they've been sitting there. That application got retired. They didn't tell you, so you have these servers that are sitting there. So using chargeback, I can put the onus on the end user that they can deploy these services out there, deploy these virtual machines through self-service, and that's okay now. I can give them a controlled environment. They can deploy them. But now I can give them a report back every month, every week, every quarter, whatever, that says these are the services you've deployed, and this would be the cost associated with them. Now, you may want to charge your business units for it and collect that money back, or you may just want to let them know what they're utilizing so that I can pull these resources away or know, hey, you've had these deployed, you haven't been using these, let me pull some of these back. We want to monitor the allocation of these resources. So whether or not these virtual machines are running, they're still taking up storage. They're still taking up space on my environment. I still have to account for them. I have to patch them. Maybe I'm backing them up or something. So I still know that they're there. So I want to monitor how much these resources have been allocated to my end users. I want to set some type of cost associated with that. RAM's cheap, storage is cheaper, but it's all still pretty expensive when you aggregate it out over time. So I want to be able to charge them back and say, we've reserved this much resources for you. And for reservation, I'm not going to charge you that much. I just want to know how much I could grow to. But you've allocated this much of that. So let me charge you on how much you've allocated. Right now, we don't have usage inside of chargeback for 2012 SP1, as far as, you've used 30% of the capacity or something like that. But we do have it charged by allocation and by reservation. And then I want to, as an organization, centralized IT, be able to get insights into how these resources are deployed and used so that I can justify either up my management chain or to the different business units why they're using that much information. And this can help me plan when am I going to run out of resources. By knowing that all of these different business units are using this much or have this much reserved, I know that, well, if everybody deployed everything, I'm over allocated, so let me buy some more resources and get that ready. The other thing we've done within System Center 2012 SP1 is with Orchestrator, besides upgrading support to support Windows Server 2012, we've also included things like the Windows Azure IP pack. So now I can do things against my Windows Azure virtual machines that have been deployed up there, or I can extend services or that type of thing. Mike will talk about that in a few seconds. The other thing is that we've updated support for some of the management packs that we've already delivered, like Azure Directory, Tivoli, HP, Windows Azure, FTP, our VMware vSphere integration pack. We also have a lot of partners that are building their own management packs to support integration with third-party systems. So besides the ones that we've updated with SP1, like the Exchange Management Pack, the Windows Azure, and the FTP Management Pack, our partners have also created management packs to support their new capabilities. Like NetApp has one for their NetApp file system. Cisco created some for their UCS management from within Orchestrator. Third-party companies like Kelverion has created management packs so that you can support if you're using ServiceNow as your service desk tool. So we can integrate into all these third-party applications. We've done some ourselves. We've had to work with partners for other ones just because we can't purchase some of our competing companies' software to be able to create our own management packs. So we have to leave it up for a partner to do type of thing. So within Service Manager, we've updated most of the support for SP1 as well as Chargeback, Orchestrator. We've updated our management packs, especially ones with connection to Windows Azure. And so with that, I'm going to have Michael come back up and show you a little bit how Chargeback works as well as the management packs and Orchestrator.
Very much. Okay. Now, what I'm going to do, and I don't usually do this, but I'm going to show you Chargeback through DemoMate, which is a screen capture tool. And the reason I'm going to do that is Chargeback itself is Service Manager based. So, and because it's Service Manager based, it's a poll based. So effectively, every change we make takes between 3 and 10 minutes to sort of propagate through, and to build the cubes, it can take 2 or 3 hours. Once you set it up, it takes it's easy to set up, but you're going to set it up over a day, and then it's going to propagate, and then you're going to get instant results. But to try to do it in a quick demo and show you everything in Chargeback is always a little bit difficult. But effectively, Chargeback, you add some management packs to your Service Manager and your Ops Manager, and it integrates VMM, Ops Manager, and SM together to be able to do this sort of analysis of your virtual machines. So you can see here I have my Chargeback, which is new within our Service Manager, and I'll have concepts of clouds and price sheets. So if we go and create a new price sheet, so effectively here I've deployed my management packs They're propagated through. That usually takes about half an hour. We have a lab downstairs which sort of fast forwards this a little, allows you to jump through so you can sort of experience it yourself. But basically, I'm just going to go in and create a name for my chargeback sheet, put a description in, and then associate a price. So here's all the information that we can get from a chargeback. Now this extends in R2 and goes from, at the moment, chargeback is a day. We do this on a daily basis, but as we move through R2, I believe it comes down to an hour. It might even be a little bit less than that. I'm not sure what the final number is, but at the stage, if you put this in SP1, this would be a daily analysis of your chargeback. And effectively, you go through and define base price, compute price, and advanced price. And so this is your virtual machine price per day, cloud membership price per day, and then your price per core, price per memory, price per storage. This is effectively either look back or chargeback solutions. The good thing here is it deploys everything outside of this in either an analysis cube or an Excel sheet. And once you've done that, deployed that, you can either bring that into your own chargeback systems internally. So if you're running, some SAP system or something like that, you can just import that into that. We have some partners that extend our chargeback system, or you can just use an Excel-based chargeback system itself. So once you've got all this information, effectively, you're going to publish it, and you're going to assign it to a cloud. So you're going to go through and choose the clouds that are in your network, assign them to clouds, and at that stage, you're pretty much done. Analysis will actually start to happen, and then we can go and view that information. We view that information in the data warehouse. So you have cubes. You can see that I have a chargeback and now a chargeback cube associated with that. And effectively, once I've gone through and created the analysis of that cube, I can then push this information out in Excel, or I can use an API to call into that cube. So if I've got a third-party chargeback system, I can just integrate straight into that cube and pull that information out, similar to how you would pull into any sort of SQL cube at that stage. And the chargeback reports are actually quite, they can be multiple things. In itself, chargeback is really just a bunch of data. And so you can use this data in any way. So we have a nice sample where you can just grab the sample and shovel the data into the sample, and it will create you nice little visuals like this. Or you can actually use your own pivot table tools associated with that as well. So the good thing here is that you can use this for general look back and trying to understand how people are using your environment. And then, as I said, if you're starting to move into a chargeback type mode, this gives you a really good sample base rate to understand the charges that you could then utilize in your divisions in your environment. To give you an example of some of the core data that can come out, you can see this is sort of the information that you can pull out from a chargeback component. So this looks at it per day, and all that information, all that charge information that we put in the price sheets gets developed out there. So they're daily details and monthly details. But as I said, as we move through into the R2 timeframe, we can then get down to hourly details. So you can then say, I want a day, every 12 hours, every 8 hours, 4 hours, every hourly, and I'm sure we'll announce some more stuff as we go through on that as well. Now, I did want to show you quickly some of the, as Kenna was saying, some of the ops manager, orchestrator information that we have here. Where's my runbook? Now, one of the great things that we've done within, one of the great things that we did within 2012 SP1 is provide a lot more integration into the Azure environment. And the great thing here is now you can utilize orchestrator runbooks to actually write into Azure. So this is an orchestrator runbook that we created that looks at capacity and determines from a capacity point of view, if you get an alert, it examines what the alert is, determines if the alert's a capacity alert, and then it makes a decision based on the capacity of either your on-premise cloud or private cloud, if you've got the capacity to support maybe a new load or a new application. And if you don't, it will then go and create new instances in Azure for you. So it starts getting a lot more intelligence within your System Center environment to understand automated capacity analysis. This is really good if you've got a website, for example, and you're running parts of that website in your private cloud and maybe aspects of that website in your Azure environment. You're utilizing some sort of load balancer, maybe third-party load balancer, to load balance between them. What this will do is, as load increases, and you're going to be analyzing that load, both on your internal systems and on your external systems, either utilizing web application transaction monitoring or GSM, when you actually get load issues and you're going above your SLAs, what this will do is it will actually do that analysis of the capacity of your current environment. And if you're at the peak, say if you're at 80, 90% of the capacity of your environment, this will just automatically extend your capacity in Azure. Because you're utilizing a load balancer at that stage, it's going to be invisible to your clients. We've got fairly great and great tools that you can actually utilize in this situation yourself. So, for example, this basically here is going to call out a script, a fairly integrated PowerShell script to understand the capacity of the environment, pull in all that information from your VMM environment, and then make that determination from the cloud. And then it will actually write the deployment itself. So you can see here, this is just a simple PowerShell script, which we actually are going into Azure and rewriting your config file in Azure. Now, if you've ever been into Azure and you go, from a website point of view, this is a cloud point of view, not a IaaS point of view, and you've got the slider and you can slide the instances back and forth. Underneath that, you're just rewriting a config file. And all we basically do here is we just rewrite the config file, and down here we just basically add one to it. So if you've got an instance that says I've got 2 instances, we go, hey, automatically slide that to 3 instances. You've got your base web cloud package in Azure already. It just deploys a new instance of that. So it's a very simple tool, but a very powerful tool to really show you some of the orchestrator ability that we have in the Azure environment. Now we actually have some labs that walk through this. If we have enough time, we'll come back through this in the end, but I want to give enough time for the guys to show you some of the more great things within SP1, because this takes a couple of minutes to run. But with that, I'll bring one up. Talk about cross-platform.
All right, sure.
Let me go back to your slides, mate.
Yep. Right, so I'm really excited to talk about why System Center is really an enterprise-class, enterprise-scaled management solution. Because System Center, it was really good at managing the hypervisors of Microsoft workloads that's running on top of it, deploying it, monitoring it, because all our product groups are actually making their management pack with their own knowledge bases to ops managers. So whenever you deploy and use Microsoft Windows Server, client, or any of the Exchange servers that are running on top of it, you will have that management pack, the knowledge base that the people who actually created that will have that knowledge along together, so you will have a really quick way to troubleshoot all that. So that was really good, and that's probably the main reason why you were using System Center to manage your data center, right? But we also know that in a real enterprise data centers that you live and breathe along with, you will have some hypervisors that are not on Windows Server Hyper-V, and there will be some of the operating systems that are not Windows servers or client, right? Which is obviously Linux or Unix. And you will also have Java applications that are running on top of Apache or any other workloads that goes beyond Microsoft. So we have really stretched that, and now in the management space, it is so important to actually manage those cross-platform layers, right? So in System Center in 2012 Service Pack 1, we really come down with it and in multiple layers. And I would like to break it down a little bit into 3 different components that we have in System Center. For Virtual Machine Manager, obviously, we do manage hypervisors, Hyper-V, which is in Windows Server 2012, but also we do manage those ESX servers or Xen servers, right, from Citrix. So we do have that multiple hypervisors to manage within VMM, and this is really important because whenever you create a private cloud, it's going to be easy for you to abstract that into one of those resources that you have. So whenever you have multiple hypervisors within your organization and data center, you can actually use that as one of those resources whenever you create your public cloud, your private cloud, right? So VMM is able to manage that, but what's better is that you can actually deploy your Linux virtual machines with your virtual machine manager, right? So if there's a requirement on the dev team or whatever the requirements there may be for running Linux, your legacy database is running on MySQL or things like that, you will be able to use Virtual Machine Manager to have that Linux deployed. Another thing with that is whenever you deploy a certain virtual machine, first of all, you need to have the correct network setting, and you will also have to have the right host name configured so that whoever requested that virtual machine, you need to let them access to it. Now, we have the equivalent level of experience with Linux as well. So if any of you guys have used Virtual Machine Manager, you can set a static IP pool set. So whenever you deploy it, you will have one of those IP addresses and also host name relating to that so that they will have deployed it and you're right there for you to use. We also have that with Linux. So whenever you deploy Linux, you will have a set of host names that you want to configure that from and get the IP addresses without any interactions for any people who deployed that has to go into and configure that, which will save a huge amount of time for you. So that's a new thing. So you can actually deploy your virtual machine as a Linux. But combining that to a service level, you can have a service template that consists of Linux virtual machines together along with the Windows virtual machine as a single service, right? So if you have a service that's running Apache web server and you have the SQL server that's running on top of Windows, you can have that as a service as well. So it's going to be like in the real environment, right? You will have cross platforms, and you will have to have that managed as a service template. The good thing about service template is that you can actually scale out. So whenever there's more requirements of scaling your web servers out or your database out, you were able to do that with Windows virtual machine templates and service templates. But now you can actually use that with Linux as well, so you can scale out no matter what operating system you're running on top of. So that's pretty big as well. And you would also like to use live migration whenever you want to save your powers within your host machines, because that's some cost that you want to save. And not every season, for example, like if you are hosting a shopping mall, so you want to have that reduced and save some power on it, and you're not thinking about public cloud at this point, and you're running Linux machines, we can actually have live migrated your Linux machine as well. So that's one of the things in Virtual Machine Manager. You can have the great capability around cross-platform. Now, after deploying it, you also need to have the requirement of monitoring, right? So I know that some of you have asked about, is this session going to be about Operations Manager? I am going to be talking about the cross-platform side of the world within Ops Manager, but my key area will be in Ops Manager, so please do ask me if you have anything. But I like to talk about cross-platform here. The biggest change in Service Pack 1 would be the enhanced network monitoring capabilities, right? So that's what that's what I will be showing you later. But we do have that integrated with Linux as well, right? So if you have Linux machines deployed and you want to monitor that in a network kind of a view, and even though that is Linux boxes, we will have that capability of monitoring your network infrastructure along with Windows as well as Linux, right? So what kind of in-depth monitoring capabilities you can have within Linux? Pretty much equivalent with Windows server or client as well. You will be checking the availability of that Linux machine. You'll be also checking the configuration, the performance, and the security. So that's the 4 aspects that you will be able to monitor your Linux boxes within the Ops Manager as well. And then another thing is you will have a rich set of event information within Windows Server, right? So whenever you want to troubleshoot, a lot of people goes to event information and seeks that. And the good thing about Ops Manager is that you kind of link the knowledge base with that multiple events that's occurring and shows you the right information within your organization to resolve that problem. Now, it goes the same way with Linux, but sometimes there's not event information as rich as Windows, so you will have to monitor those log files. So the capabilities that you have today is that you can actually monitor a certain directory of log files and search for a certain string, and according to that string, you can pop up alert automatically, or you will have to have a certain task related to it. For example, if you have a log file like directory like piled up, and you want to archive that into a certain directory, or you want to push that down to a tape library with other resources, you can actually do that by running a runbook as well with that. So monitoring log files is something that's really new. And you can also monitor those J2E applications as well. Right? So if you have Tomcat and running J2E application on top of it, you will be able to monitor that with injecting those BeanSpy application, and you can actually see the transaction time within the server side of the world, so you can do that as well. Right? So that's Operation Manager has really enhanced in monitoring the network capabilities along with Linux and Unix. And we also have the ACS, right? Audit Collection Services with Ops Manager. If anyone knows about that, it's great to monitor Windows servers. So you will be having audit collections with security-related information within Windows Server. So you want to track down what user has logged in with administrator rights and what time and when they logged out and what security-related configuration they've changed. So at the end of the day, you really want to have that information at the back of your data center so that you will know when to audit on a security-related events. Now, it only makes sense if you have a one consolidated ACS audit collection data information along with Linux and Unix, because you just want it together, right? So that's what we have done in Service Pack 1. So we have that correlated security level of information logged from Linux boxes, and you will have that into a single set of ACS databases within Ops Manager, right? So that's something that you can benefit from. And a little bit about Config Manager, just on the Linux and Unix monitoring side of the world. We do have the Config Manager this time around with Service Pack 1 to actually deploy, get information of hardware and software from your deployed Linux machines. So you will have that information together along with Windows, so you will see a set of applications in your data center, what's running and whatever deployment that you wish to take. Another great thing about this is that if you are running Config Manager within your data center, right, you will need to have a lot of infrastructure deployed for that, because there's going to be a huge package deployed within your data center. You want to optimize that with a lot of branch offices and some sort. Now, because we do support Linux, you just don't need to touch any of those infrastructures. You can actually reuse that infrastructure and deploy softwares, packages to a Linux box as well, right? So that's pretty big as well. And you will get the report information along with that as well. Config Manager, as some of you might have known, we do have an anti-malware software deployed and managed through Config Manager, so you can actually deploy the agent and the signatures with Config Manager. Well, you can do that to the Mac OSs and Linux and Unix as well. So that's one of those things that you can take advantage from. Right? So what are the supported operating systems? These are the supported operating systems that we do support today, so you can actually take advantage from. And you can actually, we do support that once they're out, and if the vendor supports that, which is Linux and Unix company supported, we do support that as well, right? So I'm going to quickly show you a very quick demo across those components that I've told you, right? So this is the virtual machine manager that actually uses not just Hyper-V, but a VMware clustered ESX server as well within the virtual machine manager. So we have a VMware cluster here and that you can utilize from. So if you see the virtual machine that's deployed here, I'll just click there. virtual machines and services, you will see that there are some virtual machines deployed within these host machines that consist of VMware as well. And I'd like to show you how we kind of integrated within Virtual Machine Manager of creating the Linux templates. So I'd like to quickly go there, and let me just quickly show you how I can create a guest profile. Just guest profile here, and let's say Linux compatibility here. Now we have this new Linux compatibility, so we can actually use that. And here you will see that we have various operating systems that consist of Linux, so we do understand Linux having to deploy to our hypervisors. Now, one of the things that we have changed on making Linux as our first-class citizen within hypervisor and Azure is that normally we took that Linux box, Linux machines, and then we developed from that Linux machine to actually communicate with the hypervisors within Windows Server, right? So we had a different integration component that you had to install from. So if you have a Windows Server Hyper-V and you want to upload a Linux box on top of it, you need to have an additional installation to go for to have a really nice, to run your Linux box on top of it. But this time around, what we have changed is that, I'm not sure if you guys know how Linux is made, but for example, the CentOS and the Red Hat shares the exact same kernel versions, right? So they picked that up from a Linux distro. So what we have done is we actually participated in the open source community and actually sent our integration component code to the Linux distros. So whoever picks that kernel up, they will be able to use that on Hyper-V out of the box. So from now point on, CentOS, Red Hat, Linux, if they have their most current version of kernel within their Linux, they will be able to run their Linux box on Hyper-V without any additional cost of management. So we take full advantage of that in Virtual Machine Manager. Moving forward, you can also see the newest release of Linux boxes here, and you will be able to deploy that within Hyper-V. And as I mentioned before, you can have a root credential, and I don't think I've mentioned before, but you can also have a run once command. So whenever you want to deploy a virtual machine, in an initial stage, you want to run a setup command to install your applications, or you want to configure your database, or you want to upload some of your file shares, or stuff like that. So you can actually do that here. The good thing about this is, as I told you before, you can actually have the IP address and the host name and the DNS updated as the way that you want. You will be able to install directly from the web, such as the yum commands, so that you can actually leverage that from Linux box as well. So that's one of those things that you can do here. And you can actually create a virtual machine with Linux box here. I'm just going to show you how we can do that. So from existing one, I have a CentOS that I want to leverage from here. And I'm going to rename it, right? And I can actually use the hardware configuration that I had been using for Windows virtual machines. And here, I can just check the CentOS that I've just previously built and have that, and have the root credentials if you need to. And you can actually deploy that on a file server library that I use here, exactly the same file share library that I'd be using with Windows as well. So this is something that you can actually take leverage from, and you can create a service template along with the virtual machine template that consists of Linux as well. So that's that, and I want to switch to the Ops Manager here. So I do have that deployed on my environment. If you see here, I do have a Linux Red Hat CentOS 01 is running, and I have a Red Hat, 2 of the Red Hat boxes running here. And if you see at the operation manager here, you will actually see the network, the IOs that's running on on Linux boxes, you can actually monitor them as well. So, and if I switch back to what we can, the network vicinity view, if I can find it here. All right, network monitoring, right? And I want to see a network summary dashboard here, right? So this actually monitors the network hardware switches, and we do support the SNMP protocol, SNMP version 1, 2, C, and 3. So we can actually leverage that as well. So any of the switches that support SNMP version 3, we can actually have that integrated within Ops Manager. So whenever there's an error, you can actually go drill down to the network level, which is pretty huge, right? So I like to go to network vicinity view. This actually monitors from your data center's network device connected to any of the Windows or Linux machines. Now, another great thing about this is it doesn't really matter if it's on a physical or on a virtual machine. So you can actually monitor them with that as well. If I see show computers, and if I just increase a little bit of a hop, it will actually monitor from that switch or the router that I have picked up, and actually shows that automatically, so you wouldn't have to really know how your network infrastructure is made up of. So it's actually going to get that from the real environment here. So now you will actually see what kind of machines that has been connected to. You will also see that switch that is not currently working, so you wouldn't really know what's connected here, but you can have the good visibility around how healthy your network environment is, right? So yeah, I just wanted to highlight that. So on the cross-platform scenario, so what you have seen now is that with Virtual Machine Manager and with Ops Manager and a Config Manager, you can really confidently deploy your Linux applications, Linux VMs, and monitor that into a lower level as networking stack. So that's pretty big, and that's pretty much of what we can actually do today with Service Pack 1. And I'd like to switch gear a little bit and talk about backup and recovery. I'm not sure if any of you have known or heard of Data Protection Manager. That's one of the key components within System Center. This is for this Service Pack 1, there has been a huge improvement on DPM, right? And I'd like to kind of talk about that, especially when it comes around our Microsoft workloads, right? If you want to have backup your Microsoft workloads, especially on Windows Server 2012, Hyper-V, Active Directory, Roll File Share, and also some of those applications such as Exchange, SQL, SharePoint, Dynamics. We all do support that out of the box with DPM on that. And especially the key thing is that DPM actually supports in an item level, backing up in an item level, which means is that on SQL, SharePoint, you can actually have a specific item backed up with DPM and have that monitored through Ops Manager. So the good thing about that is we have a lot of backup and recovery solutions out there in the real data center. But if you back this up in item level, it's going to take you such a little time for you to recover, because the item itself, it's going to be recovered. The size is so small, you can actually recover that in a very quick, instant way. So we do support that in the item level recovery. We do support backing up every 15 minutes with that, so that's pretty big. And the Ops Manager is monitoring that, so you can have that recovered through the disk base. Also, we do support a tape-based backup. So if you have a VTL deployed in your environment, you can actually connect that and save that there, right? And the biggest thing that we changed in Service Pack 1 is that we can actually back this up to Windows Azure, right? So on the keynote, you have seen the Hyper-V replication manager within Windows Azure, so that was big. But this is what you can actually utilize and use today in your data center, right? And we have a data person recovery site, disaster recovery, so you can actually recover in a whole site base with data DPM, right? So one of the key things, most of it I did mention that. I do want to call out that we do support SQL 2012 always on. I'm not a SQL expert, but SQL always on is something that actually can put it always on with a database. They have multiple databases, so it will point you out to the living database that you have in SQL. But SQL, the DPM understands always on, so whenever that's switched back, you will be able to back that SQL database as well. So that's something that we support with DPM. And the biggest thing with System Center as a whole is that we do support Windows Server 2012. Now, DPM also plays along with that story, so we do support the limitations, until the limitations of what Windows Server 2012 can bring. We do support 64 nodes with 8,000 VMs, so we can back that up as well, and architectural-wise, we do support that. And live migration, whether that's live migrated, we do support that. And we do also support the deduplicated volumes, so that DPM understands the small amount of deduplicated volume, so that you wouldn't necessarily need all that storage space for it, right? And Hyper-V over file share, the SMB, support that as well. And DPM can be run as a Windows Server 2012 virtual machine, right? So that's what I wanted to pretty much cover, and I'll take it back to Kenan. Yep, here you go.
Thanks, Juan. No problem. All right, and then the last topic we're going to cover today is Virtual Machine Manager. Now, within System Center 2012 SP1, main support was for Windows Server 2012, and that's nowhere as evident as in Virtual Machine Manager, because a lot of the new capabilities of Hyper-V inside of Windows Server 2012, we needed to be able to support for our customers to be able to start implementing Hyper-V. So here's a big list of all the new features we came out with VMM 2012 SP1. Biggest thing here is we support the 2012 of host, but all the other new capabilities that come with it. So in Windows Server 2012, the iSCSI target of Windows Server 2012 is based on SMIS, and we with VMM support SMIS as a protocol. So now I can take a 2012 iSCSI target, have all my storage there for my virtual machines, use VMM to provision those LUNs, allocate them to the different hosts, and manage it via SMIS. We support the capabilities of the Hyper-V with the cluster, the 64-node clusters with the 8,000 virtual machines inside of there. We've upped the host and guest support limits inside of VMM, 1,000 hosts, 25,000 guests. Things like network quality of service that Hyper-V added inside of Windows Server 2012. We support that inside of VMM by being able to create these things called port profiles, and those port profiles can specify quality of service for VMs. I'll show you that in a little bit. Support SQL Server 2012 as the back-end database for VMM, as well as the ability to deploy and configure in a service template SQL Server 2012. Guest customization capabilities, now you don't have to be a member of the domain, so multi-tenant support. I can use VMM and have different domains inside there if I was a service provider, different companies. If I was an organization, maybe different business units. They may have different domain infrastructures. I can now deploy virtual machines for that domain without having VMM be a part of that domain. So I can do that with run-as accounts and delegation and certificates and capabilities of passing through there. We've improved performance. So by supporting more hosts and more guests, we want to make sure that as you're viewing those virtual machines, getting that information from Hyper-V and such for those guests, that we can handle it and view it in a more performant manner. We added some capabilities like Juan was talking about, where we can support and customize guests, Linux guests. We do that support and guest customization within a service template. So if I have a VM template for a Linux guest, and I want to do that customization, I got to deploy it on a Hyper-V system, and I want it to be part of a service template. So maybe if it's just that one VM, make it a one-tier service template with just that Linux VM, or if it's part of a multi-tier system, I can do that. We added support for vSphere 5.0, so now we support vSphere 4.1, 5.1, and 5.0. We had to make a choice in System Center 2012 which version of VMware to support. We supported the latest, 5.1, and now we've added with SP1 5.0 support as well. Support for things like shared nothing live migration, storage live migration, all those things we support inside of VMM. I'm going to talk about a couple of different places as well. One of the biggest work that we did inside of VMM was to support the Hyper-V network virtualization stuff that they've done. The ability to create these tenant isolated networks using the NVGRE, the generic routing encapsulation capabilities inside of Hyper-V. So to do that, we had to change and update how we support networking. And so we've created these things called VM networks. VM networks support the connectivity of the virtual machine. So think of a VM network as looking from the virtual machine down, what is that network I'm connecting to? What's the subnet that I'm connecting to there? So I can create multiple different VM networks for my different tenants, and each of those VM networks can have different or the exact same IP ranges. But because of Hyper-V network virtualization, they're going to be totally isolated from one another. So technically, I could have two companies, like Coke and Pepsi, running on the same VMM server with the exact same IP structure, and they would never be able to talk to each other because of the network virtualization. They would still see their IP addresses. I would still be able to route out and connect to my internal networks or whatever, but they wouldn't be able to connect to they wouldn't be able to cross-pollinate. Then we've also updated and created this thing called a logical switch. A logical switch is a definition that defines the capabilities of what I'm applying to those physical adapters, what the virtual machines are allowed to do. So think of it this way. I create a logical switch definition, and I store that in VMM. Then and that definition could have things like, what's the bandwidth I'm allowing for these virtual machines on there to access? I can create a service like a high bandwidth, low bandwidth, medium bandwidth. And the high bandwidth gets full access to the network. Low bandwidth gets capped off at 30 megabits a second or something like that. So I can specify quality of service for the VMs. I can also specify things like my physical NICs. Am I going to use offloaded TCP/IP offload? Am I going to do NIC teaming? Am I going to leverage VMQ or SRIOV or any of those capabilities? And I can build that into the logical switch definitions. Then I apply those logical switches with these, inside the logical switches I have these port profiles that define those things, and I apply them to the individual hosts, and all the hosts that I'd apply this logical switch to would create a virtual switch using the new Hyper-V virtual switching capabilities. And that way I can define, okay, this host has this logical switch, this host has the same logical switch, now they can talk to each other type of thing. And I can define it once, apply it to all the different Hyper-V servers I want to use. So a logical switch has these capabilities where I give it the native switch settings. So what am I going to do for the physical adapters? Am I going to add any of these switch extensions? With Windows Server 2012 Hyper-V, we introduced the extensible switch. Like Cisco Nexus 1000V has created an extension onto that switch, or Five9 has created a firewall extension on that switch. Inmon has created this S-flow monitoring for the switch. I can assign those physical switches inside the logical switch definition, and when I apply that to a physical host, it'll apply those extensions to that host as well. So I can do it on the physical adapter. I can also create port profiles for the virtual side, and these port profiles define this type of virtual machine. If I apply this port profile to it, gets these capabilities. And maybe it's how much throughput it gets. Maybe it's, do I turn on router guard or DHCP guard or any of those types of things. I define that inside of the port profile, assign those particular port profiles to this switch, and then for all the adapters, say in Building 44 production, when I apply this switch, it gets all of these capabilities. The port profiles assigned to it and such. But I can also create these classifications that go across platforms, across buildings. So I create a second logical switch for my Building 27 development environment, and I have two port profiles, one for production, where it says for high bandwidth, let's say for the database it gets high bandwidth, which means full access. But that same DB classification for the other network environment may say, I only want them to have half of the bandwidth throughput. So I can create different classifications. The classification can assign across different switches, but depending on which switch I've assigned it to will depend on the adapter, and whatever the adapter says will allow me to tell it how much throughput it is. So that way, I can create a virtual machine template that says use the high bandwidth, and depending on where it's deployed, we'll get the capabilities that that adapter, physical adapter would support or something like that. I think I didn't explain that exactly right. So if I take another example of that, let's say I have two physical hosts. One host has a lot of the new technology like SRIOV, can do a lot of offloading, has maybe a 10 gig networking switch. And then I have another host here that has a 1 gig networking switch, doesn't have TCP offload or anything like that. They're in two different environments. When I deploy a virtual machine, I want it to get the most of whatever system it's on. So when it's deployed to the host with the SRIOV, I want it to use SRIOV. When it's deployed with the other host, I want it to get full bandwidth. So when I create that VM template, I assign the DB classification to it, and then when it's deployed, whichever host it's deployed on, it gets the advantages that I've assigned to that host. I think that makes a little more sense than what I was explaining before. But these logical switch profiles I can create, and I can assign to the hosts, and that way I create it once and assign it multiple times. I think we're pretty much running over time, so the other thing I was going to do was show you a couple of things inside of VMM. Instead of just showing you VMM in the demo, what I would recommend is we have a couple of VMM network sessions, a What's New in 2012 R2 that's coming out session for VMM as well. So I would recommend going to them and seeing some of the new demos of the new stuff that's coming out there. We really appreciate all your time coming in today, and if you have any questions, we'll be up here for a few more minutes as we're tearing down and the next people are coming in. Thank you very much, and enjoy the rest of your TechEd.